Okay, Bismillah ar-Rahman ar-Rahim. So we will solve these problems. I suppose that you already have a good understanding of all those equations. If I may write them again, we had about 6 formulas, and the first two formulas were single payment formulas, 1 and 2. One was single compound amount formula, and single present worth formula. And then there were 2, light is not good. Desks. Fine. Okay. And these formulas were single payments. The rest 4 formulas were uniform series of payments. And what we have is, for example, we have, if I may close this one for a while. It's not working. Okay. The first 2 formulas are simply, for example, you have a present value P and you want to see after n number of years, okay, 0 to n, what will be the future n value. So it is Fn is equal to P into 1 plus I raised to power n. I is the interest rate, and n is the number of periods, P is present value, F is future value. This is a single compound amount formula, single payment is there, and this is our equation. The second equation is coming from the same equation. We have the present value just by manipulating this equation. Okay. Then there are 4 more formulas which are uniform series, compound amount formula, then we have uniform series, what we call it sinking fund formula, and then we have the uniform series present worth formula, and uniform series capital recovery formula. Now for uniform series we assume another symbol, we call it A. A is annuity, which is a uniform series of payments. So for example, if we are over here and each year maybe we are putting, at the end of each year we are putting some A value here, right, and we put it for n number of periods, then the formula says that the future value Fn, this is n, this is 0, 1, 2, 3 and so on, it says that the future value will be A into 1 plus I raised to power n minus 1 divided by I. Okay, As you can see, there are n number of payments, and we have this formula. This is called uniform series compound amount formula. And from the same formula, uniform series sinking fund formula, for example, if we want to find out that we have the future value, something we want to have a fund in the future, how much money we have to put in equal amount such that we have this amount, then just manipulate this and we will have uniform series sinking fund formula. Then the last two formulas are also very easy. Just you have the, here you have the future value. Please note, this is the future value Fn. If we want to have a present value, what we have done, with this formula we have taken all the payments in the future. If we want to bring it to the present, we just have to use this equation, which means 1 plus I raised to power n divided, then this equation will become the present worth formula. So we have P is equal to A 1 plus I raised to power n minus 1 and I into 1 plus I raised to power n. This 1 plus I raised to power n in the denominator has come from this. You just bring this future value to the present value here. So this is the present worth formula. All right, and the same formula, if you have a something like present value of something and you want to bring it to you want to find out how much equal series of payments you have to make to cover this initial capital cost, then we just use the capital recovery formula, which is A is equal to P into I into 1 plus I raised to power n divided by 1 plus I raised to power n minus 1. This is called capital recovery factor. And this is called, within the bracket, it is called present worth factor. Present worth factor. These two formulas are quite useful. Last time I told my class that, for example, you have a power plant and you want to recover, the power plant has 30 years of lifetime and you want to recover your capital cost. How you can recover is using this formula annually if you want to recover, and you can make tariff out of it also. How to make the tariff? You just know how you are going to charge annually from the customers the capital cost, and you can find out the value. So these capital recovery factor formula and these present worth formulas are very useful formula. Now you have all the formulas here. Okay, you have the single compound amount formula, which is this one. Single present worth formula is this one. Uniform series compound amount formula is this one. Okay, uniform series sinking fund formula is this one, and of course this present worth formula, and this is capital recovery factor formula.
Doctor, if I may ask, would these formulas be provided in the exam?
Yes, they will be provided in the exam, and we don't expect that you will even memorize or even know how to develop them or etc. Just they will be provided, right? Any other questions? No. Okay, so now we go back to our application exercise. You have all the formulas here. Now we will see that you can use those formulas to find out the required thing here. So let us see problem number 2. Problem number 1 is very easy. It is just to show that the compounding effect is really great. It is exponential. You can try this problem if you have not tried it. Have you tried this problem earlier? Some of you have tried, because I did in class, in the other class. Some of you perhaps have not tried it. Try this one. This is very easy. 200 years ago, a country borrowed $1 from a bank at 10% interest and did not pay it for 200 years. What amount the country owes to the bank now after 200 years? You just have n is 200 years, and n is 200. P is $1 and I is 10%. So use the formula. Which formula will be used? The first one. Rather the second one, we can say that. Okay, first one, yeah, you are going to find out the future value. So first formula, you use that and find out the how much will be the amount coming.
89 million.
It's about $190 million. So you can see that $1 has become $190 million. And if you have $1,000 borrowed, then it will be $190 billion will be there. So it's, you can see the magic of compound interest. Now see the problem number 2. Problem number 2 is the annual maintenance on the parking lot is $5,000. What expenditure would be justified for resurfacing if no maintenance is required for the first 5 years, $2,000 per year for the next 10 years, and $5,000 a year thereafter? Assume the cost of money is 6%. There is a hint given. Note to solve this, assume after 15 years, both options become equal. What are those 2 options we have? In management decision making, most of the time we have as a default, do nothing is one of the option. Okay, do nothing is one of the options. So do nothing is one option, which means that you don't resurface and find out the total present cost, and then using these formulas, the formulas are with you. And then another option is that you do resurfacing. But for resurfacing, you have to invest and pay for that resurfacing. But then if you do that, you will have first 5 years 0 cost, and then next 10 years you will have $2,000. After 15 years, both the options, do nothing and resurfacing, will become equal. So your analysis is only for first 15 years. All right? Now try to solve this problem. Try to solve this problem, and for solving such problems, it is good to make cash flow diagrams. Okay, the one I showed you like that. Try to make this cash flow diagrams, and we will see if you can solve it. So we have 2 options. Option number 1, let's call it option number 1, which is do nothing. If you do nothing, you have to keep spending $5,000 each year. If you do resurfacing, then first 5 years 0 cost, next 10 years $2,000. But resurfacing required some investment, something you have to spend earlier. So the question is asked, how much you are willing to pay, maximum willingness to pay for this resurfacing. So it says what expenditure would be justified for resurfacing, which means what is your maximum willingness to pay, all right, for these 2 options, for this resurfacing option. For example, if a contractor comes and he says that I am willing to do this resurfacing for $40,000. Should we go for it, or should we don't hire this contractor? So that is the question. That can be solved by knowing what is your maximum willingness to pay. All right? So if you see that if there is no time value of money, if there is no time value of money concept, you see these interest formulas are because of the time value of money concept. All right? So if there is no time value of money, then you can say that $5,000 for 15 years. So it's about $75,000. Okay? If there is no time value of money. And there we have first 5 years, 0 multiplied by 5, nothing, plus $2,000 multiplied by 10. So we have $20,000. So if there is no time value of money concept there, you can see that your willingness to pay is up to $55,000. Right? Because there is a benefit of $55,000. So if the contractor comes and he says, let's say I'm willing to work for $40,000 to do the resurfacing, if you don't take into account the time value of money, you will say, yes, it's a good deal. You are going to make $15,000, right? But let's take into account now the time value of money, the interest, the opportunity cost of capital. All right? So now try to solve.
Doctor, if I may, do we have 3 scenarios? One is do nothing, one is no time value, one is with the 6% that we have. Do we have 3 scenarios?
No, we don't have 3 scenarios. We have only 2 scenarios. This is just for learning purposes. I'm telling that if we don't have the time value of money, we can see that the maximum willingness to pay is coming $55,000.
But that's different from do nothing.
For do nothing, this is the option do nothing, that if we do nothing, this is option number 1, call it option number 1. If we do nothing, we have to pay, keep spending $5,000 each year for 15 years. And remember that after 15 years, both the options become same. So we don't worry about 16th year. We only worry about the first 15 years. So we have $5,000 multiplied by 15, we have $75,000, the cost of 15 years. All right? And for option number 2, if we go for resurfacing, first 5 years, 0 cost. All right? These are dollars here. The next 10 years, we have $2,000 spending each year. So if we have no time value of money concept here, then we say that this is costing us $75,000 and this option is costing us $20,000. The difference tells us that how much you are willing to pay for this resurfacing. So the question is asked, how much you are willing to pay for this if we take into account the time value of money. Now all the formulas are in front of you. You decide which formula to use to find out this time value of money. And maybe we can ask, or we can say that if the contractor is saying $40,000 I'm willing to work for, find out is it a good deal or a bad deal. What is this?
Construction.
Construction, okay. So shall we continue, or some smart guy would like to come and wants his face to be seen on camera to solve this problem? Maybe because of the time shortage, we continue?
Yes, please.
Okay, so I will explain how to solve this problem. Such kind of questions, it is recommended that you draw the cash flow diagram. All right? So let's first draw the cash flow diagram. We have option number 1. Option 1. It's not very sharp one. We have option 1 in which we can draw the cash flow diagram. We have, let's say this is 0 year here, 0 start, and then each year. Now in this kind of problems, we normally assume that although the maintenance is going on maybe on monthly basis or weekly basis or whatever, we assume that $5,000 occur at the end of each year. So we have each year 3, 4, 5, and we have this up to 15 year, $5,000 each year. So 1, 2, 3, 4, 5, and up to 15. For the 16th year, as I said, that the two options become only same, only one option. So we have option number 1. Option number 2 is, now option number 2 is that you have to spend initially something, resurfacing. Okay? And then you have first 2, 3, 4, and 5 years, 0 cost. And then we have from the 6th year, we have cost $2,000. So it's from 6, 7, 8, start of 6, end of, please note also, end of year is the start of next year. So end of 5th year is, we are assuming that end of each year the cost is occurring. So end of 5th year is the start of 6th year, all right? And this is 15. We have $2,000 here. Okay? Now what we are after is, basically we want to find out what is this maximum willingness to pay for this resurfacing. How we can solve this? The formulas are with us, and we can do with present worth analysis. So let's use this formula to find out what is the present worth of cost here, okay, and call this P10, 0 mean at 0 year, at the start of that. So find out P10, and P10 can be easily found. We have A is what? Equal series of payments, so it is 5,000 here, and then we have 1 plus I. Now I is how much? 0.06. So I will just write 1.06 raised to power, how many years are there? 15. So we put 15 minus 1 divided by 0.06 into 1.06 raised to power 15. Please note one thing. Sometimes students make mistake, they make it 15 minus 1. It is not 15 minus 1, it is minus 1 separate, okay? It is not raised to power minus 1. Clear? So now this P10, find it out, please everybody, and should also know how to use the calculator. Sometimes the students also make mistake in calculations as well. Try to find out this. Okay, so I will write down $48. Please one by one, one digit by one digit. 48 561 and 0.2. Okay. So we can neglect 0.2 if you like. Now, regarding this one, how we will use this equation? We know that there are 10 equal series of payments here, right? Same equation, but when you use this equation, what will happen is, as you can see from here, that when you use this equation, it will come 1 year earlier here. Okay, everything comes here. So when you use this equation, the total amount will not be accumulated here, but it will be here. So first find out this amount. Okay, so first I found out this amount using the same formula, and we have, let's call this as P25. Find out this P25. P25 is equal to $2,000, 1.06. Now only difference is here is we have 10 here minus 1 and divided by 0.06 multiplied by 1.06 raised to power 10. So please solve this also. 14720 now this is this amount has come over here. We want to have, because we have to compare. The first one has come here, present value. This one is over here at 5th year, the start of 5th year. So we want to be at the start of 0 years. All right. So how we will do that? Now this has become a single payment. So we will use the single payment formula and bring it back. Single payment formula is P is equal to F over 1 plus I raised to power n. So if we want to find out P20, bringing it over here, it will be, now this has become future value for this. Please note that. These are all relative. This is a future value for this value. So our future value is now $14720 over 1.06 raised to power 5. So bring this value back.
Almost 11,000.
Okay. So we have P20 is $11,000. Okay. Now the maximum willingness to pay, as we did for without taking into account the time value of money, took the difference to find out the maximum willingness to pay, right? Now we have the maximum willingness to pay is just the difference of P10 minus P20. That is your maximum willingness to pay. Okay, maximum willingness to pay is P10 minus P20. And who will tell me that?
37,561.
So $37,561 is our maximum willingness to pay. So we can see that if the contractor is asking $40,000, what we will say to him? No. Thank you very much. We don't need your services. Right? However, if we see from here, it looks a nice proposal that if we don't take into account the time value of money, we see that we will be making $15,000. But if we took into account the time value of money, we have seen that actually the maximum willingness to pay is only $37,561. Clear? Any questions? Okay, let's move on then. This is another application exercise. And again, you will be using these formulas which are given to you, the application of those formulas. Here I read that Mr. Jones wishes to establish